So let's get started with the entire process step by step, and I'll walk you through it carefully. The very first thing that you need to do is to draw your precedence network diagram and then gather all of your activities together in one place. That's the initial step that you absolutely must take before moving forward, so make sure you have that diagram ready. After you've done that, you then go activity by activity and determine the early start and early finish dates for each individual activity. In other words, you're figuring out just how soon each activity can start and how soon it can end, which is really important for the schedule. This concept is known as ASAP, which stands for as soon as possible in the context of schedule development. For each and every activity, you will record the early start and the early finish, and you do this by calculating the sum of the durations along the path leading to that activity. There's a very simple formula that you will use, and it's really straightforward to apply once you get the hang of it. The early start equals the predecessor's early finish plus 1. That's pretty easy to remember, isn't it? And note that this plus 1 accounts for the next day, if you're thinking in calendar days, so it's quite straightforward. And then the early finish equals the activity's own early start plus its duration minus 1, so you just need to keep that in mind. So you simply plug in the numbers, and y'all get those two values without any trouble. Y'all note these two values down for each activity in your network diagram or table. Now, if an activity happens to have multiple predecessors, you will use the highest early start among all of them, because you're looking for the earliest possible start that respects all dependencies. This entire process is what we call the forward pass. So in the forward pass, you're essentially moving forward through the network, calculating the early start and early finish for every activity one by one as you go. That's the forward pass, simple as that, and it's the foundation for the next step. Now moving on to the backward pass. The second step in this process is the backward pass, which is just as important. In the backward pass, you determine the late start and late finish dates. These are referred to as LOP, or as late as possible. Here, instead of adding durations, you subtract them. The formula for the backward pass is as follows. The late start equals the late finish minus the duration plus 1, and the late finish equals the successor's late start minus 1. So you work from the end of the project backward. In the backward pass, you start from the very end of the project and work your way backward step by step, using the successors to compute the dates. And this is where you start from the project end date, which you might know from the overall deadline, and then you work backwards to see how late each activity can be without causing delays. As with the forward pass, if there are multiple successors, you will use the smallest late start value among them. That's important because you want the latest possible finish without delaying the overall project, and that's exactly what this formula gives you. And that sums up the backward pass nicely. So we've covered both the forward and backward passes. Now, this entire process may seem a bit complex when it's explained verbally like this, but don't worry. You can find detailed explanations online or in project management books, and it's definitely worth practicing on paper to really get the hang of it. In general, you will create a diagram that shows all the project activities in a network. It's much like a table that includes the activity name, the duration, the early start, the early finish, the late start, and the late finish for each activity. Y'all also need to understand the sequencing of activities. First, you develop the schedule. Once you know all your activities and their precedence relationships, you will draw a network diagram. For example, let's say activity A has activity B as its successor. That means B depends on A, so you draw an arrow from it to B then. Activity C depends on both A and B, so you draw arrows from it to B and from B to C now. When you're calculating the forward and backward passes for activity C, remember that it has multiple predecessors. You compute the early start from each predecessor and take the larger value, then fill that value into CS table. You continue this process until your schedule is complete, making sure you handle each activity correctly. With all the variables in place, you will calculate the total float for each activity. That reveals the critical path. You analyze it activity by activity and path by path. You can calculate float using either set of dates, late start minus early start or late finish minus early finish. Let me give you an example to make it clearer. For instance, consider a path in your schedule consisting of activities A, B, D, G, and H. Let's consider a specific example to illustrate this. Imagine you have a path in your schedule consisting of activities A, B, D, G, and H. If upon calculation each activity's float is 0, then that path is critical. However, as I mentioned earlier, the critical path isn't necessarily the one with 0 float. Instead, it's the path with the smallest float in the network. The float could be 0, 1, 5, or any other number. The path with the smallest float is the critical path of your schedule. So you always look for the path with the least amount of slack. That's the key to identifying what drives your project timeline. So in summary, this is the method for manually calculating the critical path of a project. Software like Microsoft Project or Primavera uses this same algorithm. It automatically iterates as you input activities, durations, and predecessor-successor relationships. But it's essential to understand the concept in the manual calculation, especially for the PMI-PMP certification exam. In the exam, you're given a precedence network with activities, predecessors, and durations, and you must calculate the critical path manually. More importantly, grasping the fundamentals allows you to critically evaluate the information the software provides, rather than blindly assuming it's correct. As I said, never lose your grasp of the critical path, so always remember the critical path is crucial. It's the backbone of project scheduling, and understanding it will help you manage your projects more effectively. You'll be able to identify which tasks are most important and where you have flexibility. That's the key insight from this entire process, and it's something you'll carry with you throughout your project management career. So take the time to practice and internalize it, because it really does make a difference. And the more you practice, the more intuitive it will become.